So let's say you're given the value of the cross product, but not the actual vectors themselves. And the challenge is to find these. And of course, in order to do that, you will have to use some of the algebraic properties of the cross product and dot product and all that. Okay. All right, so let's try to do just the first one, which is the cross product of 2u plus 5v. All right. You have summation. What can you do in that case?
It's v equals 2u plus v.
Right. You can do the distribution, right?
Yeah.
So we know that distributed property holds for cross products, right? So we have v cross 2u plus v cross 5v. And when you do this distribution, it's very important not to mess up the order. Okay, I put v first because v is first. If you change the order, it's no longer true, and the reason for that is because cross product is not commutative, right? Okay, so in fact, if I want to commute this, what should happen? If I switch these two around.
V negative 2.
It's negative. It's anti-commutative, right? 2u cross v. So this is the same as negative 2u cross v, and that's nice because I'm given u cross v, so I can use this now. See why I want to switch them? Okay, what about v cross v? What's that?
0 because 0.
0. Why is that?
V times v.
Yeah, it's always true that v cross v is always 0 because if you have two of the same vector, the angle between them is 0, and sine of 0 is 0. Remember, cross products are associated with the sine function, whereas dot products are associated with the cosine function, right? So this gives you 0. Now, one thing I want to say here is that it's really not 0 as a number, it's a 0 as a vector. So in this context, it's really 0, 0, 0. That's what it is. And this is not the same as just a single 0. Let's see. Cross products give you a vector, whereas dot products give you a scalar. Okay? Always keep that in mind. Okay? And never make that mistake. Okay? When you are solving your exam problems, always write a vector answer for a cross product and a scalar answer for a dot product. All right, so it's negative 2 times u cross v can now be replaced by negative 1, 0, 2. And that's a 0, 0, 0. It doesn't matter if you add them. So you get 2, 0, negative 4 as the answer to the first one. Now let's try for b. Let's do v dotted with u cross v. U cross v is a vector or a scalar? Vector. And if you have a vector and another vector and you do a dot product, you get a scalar. So we're going to expect a scalar answer. Okay? Always try this before you write your answer because messing up with the scalar and vector business is the number one thing I look for. If you mess that up, you're going to get no partial credit. Okay? I warned you. Right? So do not mess that up. You have to make the final answer agree with what the original question is saying. Scalar, scalar, vector, vector. All right, so we have some scalar. Let's see. U cross V with V. What's the angle between this and this? Amazingly, we know that answer. What is it?
V and V.
What's the angle between this vector and this vector? 9 degrees. What is that?
Dot product is
Oh, no. By definition, U cross V gives you U cross V gives you a vector that's perpendicular to both of them, right? Okay.
So
Whose area is whose length is same as the area of the parallelogram. That's the definition of a cross product. Okay. And because of that, I know that the angle between U cross V and V are 90 degrees. It's 90 degrees, okay? Then go back to this and think about what dot products do when two vectors are orthogonal. It gives you 0 because this is saying it's norm of V times norm of U cross V times cosine of the angle between them. And because this angle is 90 degrees, I don't know what V is. I do know what the cross product is. But at the end of the day, all that matters is that cosine 90 is 0. And if it's 0, it doesn't matter what others are. It will just become 0. Now here's another way to think about this question. There's a name for such a product, right? If you have cross product with a dot, what's that called? You know? It's called a triple scalar product, right? And you can actually calculate this using matrices, right? So all you have to do is put them in order. If it's in this order, you have to put V as a row vector, U as a row vector, and V as a row vector. And calculate the determinant, right? That's how you actually calculate it. But we can't use it here because we don't know what V and U are. But then we also have the geometric interpretation of this. What's the geometric interpretation of this value? You remember?
It's the
Volume of the
parallel.
parallel pipes. That's the geometric interpretation of the determinant, right? And then think about the following. If you have U and V, you make a parallelogram, and then you're supposed to have a third vector to make this skewed box, right? Skewed box. But the third vector given is, again, V. What kind of box do you get? A flat one. It doesn't have any height. Okay. What's the volume in that case? 0. So that's another way to intuitively say, hey, this is a triple scalar product. It's a volume of a parallel pipe where the three vectors are not giving a three-dimensional object. They're all lying in a plane, so it's a flat object. What volume can it have? Nothing. Okay. So you can kind of think about more complicated situations where you have something like 3U plus 4V dotted with U cross V. Of course, you can still use the old method by using this by multiplying this, distributing. That'll be one method. But a quicker way to say it will be, well, if you have a U and a V, 3U plus 4V is some linear combination of these two vectors, so it still lies on the same plane as the plane made up by U and V. Okay? In that case, they all lie in the same plane, therefore the parallel pipe you get is again flat, its volume is 0. So that's another way to think about such questions.